In our next lesson, we're going to combine everything that we've learned over the course of these 3 days about polynomials and multiplying integers. So today's objective is students will be able to multiply polynomials with integers using the distributive property of multiplication. Now we're not just going to be working with just polynomials, and we're not going to be just working with integers, but we're going to combine the two concepts. So let's review what we've learned so far. We know that there are relationships between signs when we're multiplying integers. Let's look at that summarized table. In this table, we are thinking about what are the signs of my factors. Are my integers positive or are they negative? And based on the signs of my factors, I can then decide what is the sign of my product. Is it going to be positive or negative? For example, if my first factor is positive and my second factor is negative, then I know that my product is going to be negative. We're going to keep these key relationships in mind when we are multiplying integers with polynomials. We also are familiar with the distributive property of multiplication. And the reason why it's called the distributive property is because we are going to take our leading factor. So in this problem, we have a leading factor of 5, and we are going to distribute the 5 to each of the terms inside the parentheses. So I notice there's a 9 inside the parentheses, so I'm going to distribute it to the 9. But there's also a 4, and I'm going to make sure I distribute to that term as well. So let's think. I have a positive 5 and I'm multiplying by a positive 9. That gives me a positive 45. And I know that when I'm distributing to each term, I need to connect all my answers with a plus sign. Now, if I distribute my leading factor with the next term, 5 times positive 4, I get a positive 20. So I know that the answer to this is going to be positive 65. So we've just reviewed the signs relationship with integers and how to distribute leading factors into terms within the parentheses. Now, I also want to point out that sometimes you're not going to see this multiplication symbol. Sometimes you might see equations that look like the 5 is just in front of the parentheses, and that still means that we are multiplying. Or sometimes we might have a factor that's behind the parentheses rather than the leading factor. So let's go ahead and think about our new ideas. We need to think of distributing the leading factor with each coefficient. So we know that when we have polynomials, we have expressions or terms inside the polynomial that have coefficients. For example, there is a coefficient of 2, there's a coefficient of 8, and then we have a constant of negative 9. So it's the same idea. We're going to take our leading factor, which in this example is 5, or positive 5, and we're going to distribute it to each leading coefficient or constant if there's no variable. So if I'm thinking about if I have positive 2x cubed, and if I have 5 of those, positive 2x cubed. There's 2, there's 3, there's 4, and there's 5. If I think about what do I have when I have 5 groups of positive 2x cubed? When I add these all together, I get a positive 10x cubed. I'm then going to now distribute my positive 5 with my positive 8x. I'm thinking of the same idea of having 5 groups of positive 8x, which means I have a total of positive 40x. Notice how the expressions or the variables haven't changed. The only thing that's changing is there is a product of the factor with the coefficient. So 5 times 2 is 10. 5 times 8 is 40. Now we're going to do the same thing with our last term, which is our constant. Positive 5 times negative 9. We know that if we have one negative, that means our product needs to also be negative. So this is going to be minus 45. So when we distribute this leading factor, we end up with a final answer of 10x cubed plus 40x minus 45. Let's go ahead and take another example. I'm going to think about and address, what if I were to only distribute the first factor to the first term and nothing after it? This is a common error that I notice when students are multiplying factors with polynomials. They only distribute to the first term. So they may say 5 times 2x cubed is going to give me that 10x cubed, and then they keep everything behind the expression the exact same. But we don't want to do that. This is something that we want to not do, and we want to make sure that we distribute to each term. Now that we have that error in our minds, we're going to avoid doing that to make sure that we are distributing to each term. So let's practice together. We now have negative 6 times the polynomial 9x to the fourth minus 7x squared plus 10. So when I distribute each term, I'm going to draw those arrows again to make sure that I am thinking about taking my leading factor and multiplying it out to each term, whether it is a coefficient with variables or it's constants. So negative 6 times 9 gives me a negative 54, and I keep the x to the fourth. Negative 6 times negative 7x squared, since I have two negatives, it's going to end up being positive. 6 times 7 is 42, and I keep the x squared. And then lastly, my negative 6 times my constant of 10 is going to give me a negative 60. That is my final answer for this expression after I've applied the distributive property. Now it's your turn. I want you to think about the problem that you see, negative 8 times the expression negative 4x to the fifth minus 9x cubed plus 3x minus 8. What do you think the answer will look like? Try it out. And after you're done, why don't you take a look at a more challenging problem? What if we think about order of operations when we're distributing integers and then adding polynomials together, like this problem? I'm giving you the hint of order of operations because I want you thinking about solving this problem into two parts. Here is part 1. Here is part 2. Once you have used the distributive property to distribute the leading factor of 7 and 8 with my polynomials, think about how am I going to combine them together when I'm working with two completely different polynomials after distribution. I want to see which scholar is going to get this problem correct. Good luck!